Hello friends, I am Ms. Priyanka Jirge, Assistant Professor in Department of Mathematics at Art Science and Commerce College Ramananagar, Burli. Today we will study definition of skew-symmetric matrix, properties of symmetric and skew-symmetric matrices, and examples on it. So let us see definition of skew-symmetric matrix. So let us see definition of skew-symmetric matrix. A matrix A is equal to Aij is said to be skew-symmetric if ith element of A is equal to negative of jth element of A. Sorry. Is equal to negative of complex conjugate of jth element of A. A matrix A is equal to Aij is said to be skew-symmetric if ith element of A is equal to negative of complex conjugate of jth element of A. That is, a matrix A is said to be skew-symmetric if Aij is equal to minus Aj bar for all I and J. For all I and J. Let us see the example to clear the definition of skew-symmetric matrix. Let A is equal to minus I, 2 minus 3I, 4 plus 3I. Then minus 2 minus 3I, 0, 7 minus 5I, minus 4 plus 3I, minus 7 minus 5I. Here is minus 2I. So let us check whether this matrix is skew-symmetric or not. So we know that a matrix A is said to be skew-symmetric if we get Aij is equal to minus Aj bar for all I and J. So here minus I is placed at first row and first column. So our A11 is minus I. We take its conjugate. So A11 bar is equal to I. Therefore, we have A11 is same as minus A11 bar. Similarly, we have A22 is same as minus A22 bar. But here A22 is 0 and 0 bar is 0. And A33 bar is equal to and A33 is equal to minus A33 bar. Since A33 is equal to minus 2I and its conjugate is 2I. Therefore, we get A33 is equal to minus A33 bar. Now, this 2 minus 3I is placed at first row and second column. Therefore, A12 is equal to 2 minus 3I. Now, we take its conjugate. A12 bar is equal to 2 plus 3I. Now, minus A12 bar is equal to minus 2 plus 3I, which is same as -2 minus 3i, but which is same as our a21. Therefore, here we get a21 is same as minus a12 bar, and similarly we can get a12 is same as minus a21 bar. Now 4 plus 3i. Now 4 plus 3i is placed at position first row and third column. Therefore, a13 is equal to 4 plus 3i. Now we take its conjugate. So a13 bar is equal to 4 minus 3i. Therefore, minus a13 bar is equal to minus 4 minus 3i is equal to minus 4 minus minus plus 3i, but which is same as a31. Therefore, here we get a13, therefore here we get a31 is same as minus a13 bar. Similarly, we can get a13 is equal to minus a31 bar. Now 7 minus 5i is placed at second row and third column. So a23 is equal to 7 minus 5i. We take its conjugate. a23 bar is equal to 7 plus 5i. Therefore, minus a23 bar is equal to minus 7 plus 5i is nothing but minus 7 minus 5i, but which is same as a32. Therefore, a32 is same as minus a23 bar. Similarly, we can get a23 is equal to minus a32 bar. Therefore, here we have aij is equal to minus aji bar for all I and j. Therefore, this matrix A is skew symmetric matrix. Now, let us see another things related to skew symmetric matrix. So, I take same example here. Let A is equal to minus I, 2 minus 3i, 4 plus 3i, minus 2 minus 3i, 0, 7 minus 5i, minus 4 plus 3i, 7 minus 5i, minus 2i. Now, we take its conjugate. So, A bar is equal to, we take conjugate of each elements of A. So, conjugate of minus I is I. Conjugate of 2 minus 3i is 2 plus 3i. Conjugate of 4 plus 3i is 4 minus 3i. Conjugate of minus 2 minus 3i is minus 2 plus 3i. Conjugate of 0 is 0. Conjugate of 7 minus 5i is 7 plus 5i. Conjugate of minus 4 plus 3i is minus 4 minus 3i. Conjugate of minus 7 minus 5i is minus 7 plus 5i. And conjugate of minus 2i is plus 2i. Now we take its transpose, that is A bar transpose, which is nothing but A raised to theta is equal to, we take transpose means we interchange all the rows and columns of matrix A bar. So I take first row of matrix A bar as a first column of matrix A raised to theta, that is I 2 plus 3i 4 minus 3i. Next we take second row as a second column, minus 2 plus 3i 0 7 plus 5i, and take third row as a third column, minus 4 minus 3i minus 7 plus 5i 2i. Now I take minus sign as outside, so minus, then sign of imaginary parts of elements of A raised to theta will change. So minus I Here -2 -3i -4 plus 3i, 2 minus 3i, 0, -7 -5i, 4 plus 3i, 7 minus 5i, -2i. But see that this is nothing but our A. That is, if A is a skew Hermitian matrix, then we get A raised to theta is equal to -A. Also, from the definition, we have AII is equal to -AII bar, which implies AII plus AII bar is equal to 0. This will happen only if these AIIs are either 0 or purely imaginary number. So, we get if A is a skew Hermitian matrix, then every diagonal elements of the matrix are either 0 or purely imaginary number. Let us see one theorem. Theorem 1. If A bar is the conjugate of a matrix A, if A bar is the conjugate of matrix A, then we have first A bar its bar is same as A. Second, K into A its bar is same as K bar into A bar, where K is any complex number. That is, if A bar is the conjugate of a matrix A, then we have A bar its bar, that is conjugate of conjugate is same as same given matrix, and K into A bar is same as K bar into A bar, where K is any complex number. We do not have proof of this theorem, but we have to use it for solving the examples. Now let us see theorem number 2. If A raised to theta and B raised to theta are transposed conjugates of A and B respectively, then we have first A raised to theta is same as A for every matrix A. Second, K into A raised to theta is same as K bar into A raised to theta, where K is any complex number. Third, A plus B raised to theta is same as A raised to theta plus B raised to theta, and fourth, A into B raised to theta is same as B raised to theta A into B raised to theta is same as B raised to theta into A raised to theta. Again, we do not have proof of this theorem. We have to use it to solving the example. So let us see examples on symmetric and skew symmetric matrices. First example, if A is a Hermitian matrix, then prove that RA is skew Hermitian. Let us see proof of this example. Here, given that A is a Hermitian matrix, but we know that if A is Hermitian matrix, then we get A raised to theta is equal to A. Now we have to prove that RA is skew Hermitian matrix. We know that A is a skew Hermitian matrix. We know that A is a skew Hermitian matrix. Then we have A raised to theta is equal to minus A. Here we have to prove that RA is skew Hermitian. That is, we have to prove that RA raised to theta is equal to minus RA. So consider RA raised to theta, which can be written as I bar into A raised to theta, since we know that the theorem K into A raised to theta is same as K bar into A raised to theta, where K is any complex number. So now we know that conjugate of I bar I is minus I into A raised to theta, since I bar is equal to minus I. Now, given that A is a Hermitian matrix, therefore we have A raised to theta is equal to A. Therefore, I can write here A raised to theta is equal to A. Therefore, here we have I into A raised to theta is equal to minus RA. Therefore, by definition of skew Hermitian matrix, we have RA is a skew Hermitian matrix. Let us see another example. If A is skew Hermitian matrix, then prove that RA is Hermitian. Let us see proof of this theorem or example. Here, given that A is skew Hermitian, so by definition of skew Hermitian matrix, we have A raised to theta is equal to minus A. Here we have to prove that RA is Hermitian. We know that a matrix A is Hermitian we know that a matrix A is Hermitian, then A raised to theta is equal to A. That is, to prove that the matrix RA is Hermitian, we have to prove that RA raised to theta is equal to RA. So consider RA raised to theta, which can be written as I bar into A raised to theta, since we have K into A raised to theta is equal to K bar into A raised to theta. theta where k is any complex number. Now conjugate of I is minus I into a raised to theta since I bar is equal to minus I. Now given that A is a skew Hermitian matrix, therefore we have a raised to theta is equal to minus A. Therefore I can write a raised to theta is equal to minus A. So which is same as I into A. Therefore we get here I into A raised to theta is equal to IA. Therefore by definition of Hermitian matrix we have IA is Hermitian matrix. In the next lecture we will see another examples. Thank you.